Hey, welcome everyone. Good morning, good afternoon, good evening, depending on where you're joining us on this stream. I think, in the interest of us seeing many viewers joining in as we speak, uh, I would wait for another minute before we kick off. But welcome to everyone who's already joined in. Let's just give it a minute. Okay, I think we're good to go. So, welcome again, everyone. Good morning, good afternoon, good evening. Welcome to this webinar on network device monitoring. And we're going to focus primarily on network topology maps and NetFlow. And with me today, I have Costa. I think most of you know him. He's our founder and CEO, and also the chief troublemaker who's built most of this stuff. So if anything doesn't work, he's responsible. If everything works, I've done a great job. But jokes apart, welcome, Costa, to this webinar.
Hello. Welcome, guys. I hope you will enjoy this.
Okay, we expect this webinar to last 45 minutes. But of course, if there are questions pouring in, and keep pouring in your questions at any point during the webinar, you don't need to wait until the end. Even if it has to extend to an hour, we are more than happy to be here. So without any further ado, I'm going to get this webinar kicked off. Let's start with the agenda. We've got through the introductions. We're going to talk a little bit about our network monitoring offering as a whole, a little bit about how we do metrics and logs monitoring of network devices, and then quickly move on to the network topology demo, which Costa will take you through. And then the next part would be NetFlow. And like I said, questions are welcome at any point in time, and I will put them on the screen so that Costa and I can answer those. Uh, on the network visibility gap, I think we have now, big customers with Netdata, and all of them have had some of these common problems. Blind spots in complex topologies. So networks involving different vendors, different types of devices distributed across various data centers. And there are blind spots that are created because not everything is monitored in one place. Each vendor provides their own tools, or even the tools, observability tools that are used, don't provide the full single pane of glass, which results in, of course, reactive troubleshooting. All the issues are only discovered after a customer complains. And this, right, obviously causes quite a bit of panic, but also slowness in how long it takes to troubleshoot these issues. And then, in most cases, the customers have had the absence of traffic analysis or net flows, which then does not allow them to get the complete picture of what really happened during the outage. So what we've done in Netdata is try to put all of these pain points together into our network monitoring uh, offering. So we allow network device monitoring using metrics, traps, and logs, fully auto discovered, all the dashboards that just come up within a couple of minutes of configuring. And we've tried to make this as simple as possible. Then, of course, we also automatically detect and discover and provide network topologies, which is what Costa will be demoing a little bit later. We've also included BGP monitoring for most parts. The most obvious scenarios. There are still some pieces which are missing, but I think we'll cover that at a later point. And then, of course, NetFlow or network performance monitoring for all users who are used to some of the tools that call it network performance monitoring. This is what we offer currently, and we'll keep adding to the suite, as time progresses. The metrics collection, I think some of you may have already used it. We have more than or close to 300 network device profiles. So when we detect a device, we automatically map them to the relevant profiles. We also have about 1,000 device profiles for SNMP traps. The default collection interval is 10 seconds, as against with most other solutions which provide 1 minute or 5 minute intervals of data collection. In the configuration, I wanted to write 0, but then I wanted to be true to myself. There's always some minimal configuration required. That's the metrics collection part. And the next part, which is what I think I will hand over the ball to Costa, is the network topology maps. So all yours, Costa.
So, welcome guys, topologies and network topology. So Netdata supports topologies in multiple levels. We have one that is layer 2 and layer 3, but based on SNMP and network devices. So we collect CDP, LLDP, FDP, and STP, and more protocols from network devices. The idea with Netdata is that it's distributed by nature. So the idea is that when you have multiple offices or multiple data centers or multiple sites, you're going to install Netdata or on all your IT systems, of course, all your servers and VMs. But then you can appoint some of them to be the SNMP hub, let's say, within the site. This SNMP hub will be responsible for collecting, storing, and querying all the various SNMP or network device monitoring things. Now, on the SNMP world, what we have done is that we have a plugin that supports about 300 profiles. These are automated, so there is a discovery process that runs every half an hour. This goes and discovers on the segment that you have configured, or network segment, or multiple segments that you have configured. It discovers all the SNMP devices that respond. Then this builds automatically all the configuration required in order to continue monitoring these devices. And the profiles kick in at this exact moment. So the moment that a device is discovered, based on the OIDs that are discovered on the device, a profile selection is made. So at that moment, we decide which OIDs, which metrics, and which information we can collect from that device. But at the same time, we queue this for topology discovery to understand if we can extract from it structured information about what is its netboards or which devices pass through it, etc. So both of them are fully automated. So both SNMP collection is fully automated and topology is fully automated. Then the topology has a number of different methods in order to aggregate data. Topology in a layer 2 network is a little bit tricky, mostly because many of the devices are inferred. So you know that an endpoint, a laptop or a desktop or some other server passes through a switch, but all the ports, or probably multiple ports, report that they know this device, they know this MAC address. So there are some strategies there that involve deriving the topology. What we did is that we got them all. It's 4 or 5 papers. We got them all and we implemented them all, and you can choose them on the UI. Now, the next thing is how to visualize topology. So, okay, these are topologies. There are many ways. One was to probably have something algorithmically made, programmatically made, to show any hierarchy of some kind. The other is to give you an editor where you can build your own map the way you want it. What we decided, however, to do is something that we always do with Netdata, is to minimize the manual overhead required in order to have a topology. So the topology view that Netdata builds is fully automated. It's based on physics and forces and all this kind of stuff, and builds the map naturally, let's say, as devices are discovered and are available. This means that the topology map probably is not exactly 100% as you would build it by hand, but it's nice, it's beautiful, it's fast, and it's very powerful in the abilities that you give you to find the things that you want, or get information about each device and its capabilities. So can we switch to the view? Okay, so this is from our demo. This is a topology that has been discovered. So the process to go there is you go to live, you come here to the live functions of Netdata. Now we're building a new UI, so topologies and network monitoring will be a master menu. For the moment, it's here. So in the topology, you have SNMP. These are the SNMP-derived topologies. And the topology that you see now is automatically made. So these are, you can zoom, you can see exactly what happens. When you highlight a device, you can see immediately which are its neighbors. You can also click on, this is dynamic, right? This is forces, as I said, so you can rearrange stuff and they drag all the others together, etc. So you can click on on any actually of them, or any actor, and you can see the first thing is all the ports, and you can see which protocols we collect, etc., how many links we have derived from it, etc. Then you have the neighbors that we have discovered, the layer through subnet memberships that are available, OSPF neighbors, and here you can see all the labels that are related to this device. The idea here is that this is like a mini navigator, so you can click and go to the next, and you can click and go to the next, and you have back and forth here. So you can explore this topology from this actually model. But you can also do the same. So you have hover on everything. I am zooming in because the window is small. So there is, as this becomes smaller, it loses detail. So the best is to have all the detail is to have pretty good zoom. Of course, if you have a big screen, this is always with full detail. So the idea is that you can see all the devices by type, by connectivity. There is a legend here that describes what is all these links and the colors and what they mean. You can see also these bullets around all actors, so even here, all these bullets represent the ports. So the red actually on here on the port means something. It's a port that is down for whatever reason or failed. And the legend explains all the things. Now, on the map, you have the ability, this button here zooms out the entire map. So if you have zoomed in somewhere, you can click that and boom, the whole comes again. This enables the forces. So you see things moving. If you drag it, they come back. So the forces, as you press this, it tries to adjust again the diagram. Zoom in, zoom out, rotate the legend. And of course, is search. And this is the most powerful thing of this. So if you say, I don't know, London, you find the London things. I think Lon is the name, by name, of course, or by whatever else. So you can find here by IP or whatever you want. You can quickly search the map. Now, as I said, topologies, this is just SNMP topologies. And here you can define what you are interested to see. So what options you have? You can have node identity by IP or MAC address. You can have the map. This is the all devices view. This means after all inference, we derived how the map looks. But we provide 3 levels. This is deterministic, 100%. We know these devices are connected like that, but you see that a lot of devices are not connected. So it's not deterministic how these devices, the others, are connected. Then we have the high confidence. In this, some more devices are connected. And then we have the all devices mode. It's again one that is not. It's our thing. Sorry, this is our collector. So and you have then the all devices. Obviously here it's all high confidence. But if I switch, let me go here to see the office in Athens that we have. Where is this? Somewhere here. My desktop here. So if you see the same on my desktop, for example, that we have the Athens office, SNMP. So here is the deterministic mapper. This is 100% the links we know. But then you have the high confidence, you have some more, and then the low confidence, and you have even more devices and how they connect. So the idea is that this changes how accurate is the map. When we infer connections, then we use several strategies, and here are all the strategies that we have implemented. Each one of these is a different paper, research paper, that we have implemented. Now, when the map is huge, imagine there's probably 10,000 devices there or 20,000 devices there. By the way, the UI can do it. We scale it up to 250,000. But yes, so this is what I said, how I'm saying how it scales. So the first thing is that the UI itself scales. So even if there are thousands of devices there, it will scale, it will render, it will be fast. What is problematic, however, is the context, the mental overload of managing a thing so big. So how you can work with it? One is the search, of course, you search for what you want. The second is that you have a focus on selector, so you can select the devices that you want and search for them here, etc. And the depth that you want to see. So you select the device or the devices you want, and then you say, oh, show me one device around it. So I don't want to see the whole of it, but I want to see what is relevant to these devices. So this is the second way to scale it. Then that's one part of the topologies. We have also streaming topologies. Streaming topologies are the Netdata parent-child streaming topologies. So you can see here how, let me rotate this and make it a little bit bigger, this one. Okay. So this one shows, for example, 2 parents and my RPI lab. It's over here, a lot of RPIs. I love RPI, so I have many of every single version, as you see, even from RPI 1. So, and I have, you see here the topology of how Netdata streaming works. The interesting part, and this is the beauty of this, is that you go there and it says how streaming is replicated. So it says RPI 1 goes first to Plaka parent, which then goes to Constant Desktop. And you can do this for all of them. Even this is the other way around. So the idea here is that you can have you can see the topology of how Netdata, the Netdata ecosystem inside your network is orchestrated. And what I like the most, to tell you the truth, but it's not layer 2, strictly speaking, is topologies from every Netdata agent. These are topologies within the system. IT, the topologies inside each VM, each host server that you have, bare metal, it doesn't matter. And the idea there is that we track all dependencies between processes. So you can see which process connects to what other process, and which container connects to which other container. So the entire dependency tree. And what is missing, and currently we are about to release next week, is to see this across the infrastructure. So the code is ready, we are testing it currently. I'm going to show you the single node to understand how it works. And so this is my computer, for example. This is my computer. You will see here, this is my browser, Chromium. This is Netdata, it's a parent, this is why it's so big. And you can see everything else that I am running. Slack and where it connects. So this now is, it has arrows, so you can see where it connects. You can see the direction. Is it inbound, outbound? Is it the server? What it is? Now, if you go to a bigger scale, for example, here, let me switch to this tab. This is a Kubernetes node. Now you can see here, for example, oh, this is IPFIX. You can see the direction of the flows. You see these are inbound, these are outbound. You have the same view, so you can still see how many C groups are there, how many dependencies it has, so to which things this depends, dependence, how many others depend on this. So you can see again a similar view, and of course, because this is big, as you understand, this is a big thing. So the speed remains. So you can track them, you can move them, everything works. You can do rearrange them if you want. The idea here is that usually works with search in this kind of. So if I write here IPFIX, it highlights IPFIX for me, so I can find it easily. So the idea is that we are building. I find this amazing, especially at the infrastructure level. What I didn't tell you before is that this merging of topologies across nodes works for all kinds. So it will work also for SNMP. So you have 2 or 3 or 4 sites, or 10 or 100 sites, doesn't matter. Each one has its own SNMP hub. Each one has its own topology. At Netdata Cloud, you can see the entire thing all connected together. And the same happens with topologies of IT systems. Now, on the IT side, we have some interesting parts. The first is that you can group by container. You see that these are containers or systemd services. Well, in this case, a process, mainly because it's Netdata. You see it's a service, everything is services. And the icon changes if it is a Docker container. I can go to my computer probably to see a Docker container or to... Anyway, it doesn't matter. It works. Container means either systemd service or Docker container or LXC container or even VM, KVM, if you are at the host, a Proxmox server or something. And at the process level, everything returns to process level now. So these are individual processes now, not containers. So the idea is that you can have either at container level, which works great, of course, in Kubernetes, etc., but also per process, individual process, to have all the interconnects between all the processes. What is missing from here, and it's going to be on the next release, is actually to overlay now the size of this is how many sockets they have, and also the links become a little bit more intense or less intense, and it's the number of sockets that are there. So even if you hover a link, you can see that says weight 1 on the lower right. So weight 41. So these are 41 sockets over that link. What we want to do, and this will be the next version, is to actually have bandwidth visualized on top of this. Not just number of sockets, but bandwidth. The same for SNMP. And another thing that we are doing, we are already preparing a thread service for Netdata, a thread intel service for Netdata, so that all these IPs will be marked based on thread analysis. So you will know something, oops, this is a proxy, or this is a malware, or a C2 control, or something that should not be there. So these two are missing for the next version. We are building them. But other than that, this is the full, let's say, map topology abilities of Netdata at the current state.
Okay, that was a lot of speaking, and it just shows the passion with which Costa has built this. But also, I think there are some, you'll be happy to see this, Costa. So we have PVY Swiss, who says a huge compliment. And of course, that's what we have set out to do. And we'll keep adding more and more stuff.
So that's the idea, guys. The idea with Netdata is that we want to save time. There are many observability solutions out there that you can get to customize, to do this, to do that. Of course, we want Netdata to be configurable and customizable and tailored to your own needs. But I think that the best ability of Netdata is that you can manage a big infrastructure with a lean team. This is the biggest win. Fully automated dashboards, anomaly machine learning out of the box, unsupervised, topologies without you touching. These are automated topologies. We didn't do anything. These are derived by the software, by itself. And I believe that this is the biggest win.
Thanks, Costa. I mean, I do have another.
Yeah, for the NetFlow, I think we will come to the NetFlow in a while. It's now
yes, so
topology.
I'll bump that. Yes, so I will bump that question when we get to the NetFlow. And I think it's about time we move on to a little bit about what we have implemented on Network Flow. Costa, maybe you can take it. Give a high level of what is it that we've built, and then quickly on to the demo, because I already see some questions coming in about our NetFlow.
Okay, so NetFlow. For NetFlow, for those of you that know traffic engineering, NetFlow is a thing that you collect you collect details about the flows, not the payloads, but the details about the flows across the pass, across switches and routers. The idea then is that this is down to the port level. So every device, every router, for example, or every switch that exports flow information, it gives you the flows with full analysis. So it says this IP to that IP, this TCP flags, this, or whatever, all of it, ICMP, everything. So it gives you all the metadata for the flows, but it gives you this data down to the Ethernet port. So this means that if a traffic flow, a connection passes one device, at least one router, you're going to have them twice. Because in one interface, it came in, from another interface, it went out. So twice to the accounting. So usually what happens there is that engineers work at the interface level. So in order to see volumes and this kind of stuff, you need to select one interface. If you select two interfaces, then some flows are duplicates, some may not be duplicate. It depends on the interfaces that you selected. Now, the whole point of flows is to identify top consumers, of course. I want the top of whatever I want. So this must be like a cube. You can view it from different angles. And the second thing is that the ability to drill down to actually find anything interesting for you. Now, let's go from the basics. The basics are Netdata supports. It has a NetFlow plugin. It's not installed by default, so you need to install it yourself. Just that you install it, it starts listening. It listens on 2 ports, but it accepts all protocols everywhere. The idea is that it supports 4 protocols, NetFlow 5, NetFlow 9, sFlow, and IPFIX. IPFIX is like NetFlow 10. It's the equivalent term, let's say. So it supports all these protocols. The idea there is that it has its own backend database, and actually we did the trick there. We write the flows to systemd journals currently, so you can query the flows, the raw data, with journals.etl. But it's our own implementation of journals, and actually we are going to move it to something faster now. Regarding the speed, since you asked, a single ingestion agent, a single agent, can ingest about 100,000 flows per second, right? A single one. Of course, you can have as many such things as you want. Guys, the data is distributed, so you don't push everything to one place. Most of the biggest routers usually have, I don't know, 10,000 flows per second. The data, a single ingester supports 100,000. Now, these 100,000 are stored locally. It's on the ingestion point, and are queried from anywhere you are via Netdata Cloud. Netdata stores the flows in 4 tiers. So we dump into disk in journals the raw data set as we receive it. And we also dump rolled up tiers per minute, per 5 minutes, and per hour. Why we do that? Because we want the UI at the end to be quick. When you view a week of data or a month of data, we want it quick. And raw data are not that quick ever. So this means that you maintain the ability to drill down to the individual thing that you want. But usually, when you don't specify source IP or destination IP, source port, destination port, what you see is rollups. Then we have derived from this maps, not exactly topologies, geolocation maps. And we have derived also a user interface that's based on some key that you can examine, let's say, all the information that is there. Let's switch the demo, switch to my screen. Okay. So this is again in the same place. You remember topologies were here, flows. Now the flows, when it comes something like this. So it has a table that it shows what is selected. Actually, you can select from here the view. It's the same view here. You can select the group by is these columns, and also these columns here. So this, and that are determined by this list, and the same. These are rearrangeable, so you can move them around. You can select up to 10 at the same time. So this can be let's put here this. I don't know. Come on. Now country is inside country, and you can move country there. So you can group them up to 10 fields, which are all grouped together. You can export this is a table, you can download it if you want. These are roll-ups of the information. You can collapse these to actually see this a little bigger. There is hover to say what is this everything. So the first thing that you will notice is that there are AES numbers. So these AES numbers, Netdata supports, the NetFlow plugin supports enrichment. It's actually a very powerful enrichment because it has really a lot of things there. So the first is that it has per country, city, states, all this kind of stuff. We already ship with Netdata such a database. We provide also a program where if you have MaxMind or some other paid geolocation provider, we can ingest it and turn it into a data enrichment provider for flows. But also then you can have, for example, you can mark your own servers if you want, the location of your own servers, or you can attach labels for your own servers from AWS, from Azure, etc. So there is a very detailed enrichment. Actually, let me show you. It's on Learn everything. Learn Data Cloud. Let me share this. We have created this network monitoring section here. You can go to flows, and here on enrichment, this is the Intel downloader that you can change. You can configure your own data source for geolocation. But also we have, where it was, enrichment. This is really a lot of mechanisms to actually enrich your data. Even we support BGP and BioRes and whatever imaginable. So let's switch back to the demo. So here you can then, what is interesting is that you can slice and dice this the way you see fit. So this is the dicing part, but you can slice by anything. You can say, hey, I want, slice means filtering, eh? I want a specific server. I want 10, 20, not this one, come, not this one. I want, let me do it from here, it's very small. The source IP, where is it? Source, destination IP, blah, blah, blah. Sorry guys, I'm gonna open it because it's very small. Source IP address, and I can say here a server that we have 10, 20, 4, 21. What does the server do? I select it. And now you can see this is the server because I selected only this. You can see where it connects. You can see what it does. Oh, it has Cloudflare Net and it goes to Amazon and Alibaba, Anthropic. You see here everything it does. Of course, if I want, I can push here the destination IP. So if I go to the fields and say that I don't want the destination ASN, but I want destination IP, where is it? Down to the IP. So you can see. Now, this is one part. I remove the filters. So this was to show you how this works. To find something that you want, it's very simple. You just filter for what you want. And then you can see the same data as time series. So let's go 1 hour. You can see the same data as time series. So you can examine spikes or this or that, whatever. Again, the filtering is done. Again, the time series data are about the same grouping that you wanted. You can see a country map. And now this is the interesting. I will go to top 500 tokens. This is more beautiful. And you can see which countries. As you see, I am in Greece, so it figured it out. You can see where you talk. Now, you can see here a state map. The difference between the two, US, for example, is just one thing. But if you go to the state map, you can have per state what happens. But you can go down to the city. So if I go to the city, and this is very impressive and interesting. You go here to San Francisco and you have, for example, to the street address. This does not happen in Europe, but in the US it happens. Probably some data center of AWS or something is here. And of course, there is a globe view where you can have a very quick view of this is the bandwidth is the intensity on the links, and you can see how they look. You can do it with borders like this. Very beautiful to understand what happens and where the bandwidth goes. So that's it. This is NetFlow. This is what you can do with NetFlow.
Thanks, Costa.
I took it all. Did I answer all questions?
Yeah, I will. There are a few questions in here. Let me put that on the screen. This is more around dimensioning. So how many bytes per flow?
Bytes per flow is about 600. But as I said, we are trying to, we will change the backend database in a future version, probably in the next version, because we want first to scale above 500,000 flows per second per ingestion point. This is ISP level now. So we want this a lot more scalable. And the second is that journals are I/O hungry. So they need, the record on disk is a big. So this will be optimal in terms of disk.
Thanks, Costa. I think there's another question. And I think I can take this. So as of now, this is already available as, okay, I don't know whether I should call it a beta version because it's way beyond a beta version. But we do intend to have a new offering, which will be called Network Performance Monitoring for the NetFlows. But the licensing, again, like we do with Netdata, will not be based on number of flows or the volume. It will be based on number of devices. But so we don't yet have a release date, the general availability of this offering, but we expect it to happen hopefully sometime, I think towards the end of July or beginning of August. But yes, this will be a new offering and it's not part of the standard infrastructure monitoring license. All those details will be on the website pretty soon. Thanks.
However, it is on the night list. You can try it. You can experiment with it.
Absolutely. I think those are the questions I currently see. So I'll quickly move into, let's say, the summary part of the webinar, while all of you can keep your questions coming in. We're more than happy to answer those. Maybe my screen. We covered the NetFlow. Costa also went through the demo. So first thing would be why Netdata for networks. And I think as most of you probably being with the community for a long time, this was never our focus in the past. We were primarily Linux monitoring, infrastructure monitoring, when you widen it with the addition of Windows. But then we identified the gap, out there, because many customers who loved what Netdata did for infra monitoring, they could not consolidate all the network stuff. And what that means is maintaining multiple tools, having data silos, so not being able to identify the root cause. And that's where I think it's been a year and a half of us investing time and effort to put the networking together. And some of the key differentiators, like we mentioned, I don't think any other solution provides a 10-second granularity. You can actually go lower. It's something that we don't recommend.
Guys,
but 10
this
seconds
is
is the deep
adaptive. Let's focus one moment, Satya. The whole point here is not how frequently Netdata can do it. Netdata can do it per second. No problem. It's collectability per second. The key question is, can the devices do it? So Netdata can do it for all devices together, but can each device do it for itself? And this is the key point. You have some, in many cases, you have devices that have a very slow processor, SNMP processor, a very weak. So in these cases, we recommend to customize this. The default that we ship Netdata with is 10 seconds. But it can be anything you want. You can go down to 5 if your devices can do it. You can do it 15. You can have some devices per second, some devices every 5 seconds, some devices every 10 seconds. For sure, come on, it's not per minute or every 5 minutes that the traditional, let's say, monitoring systems and the providers, the observability providers do. This is high frequency.
Yeah, absolutely. And like we mentioned, we have 300 device profiles, but if there's any profile missing, guys, it would take us potentially a day or maximum a couple of days for us to turn around and add profiles. But you can also create your own custom profiles. But most importantly, no extra infrastructure needed in terms of collectors or probes to be able to collect all of the network monitoring stuff. All right, we've kind of consolidated the observability problem into where the agents need to be deployed. You don't need additional infrastructure or additional resources dedicated to monitor your network devices. And I think that's one of the key differentiators. And then, of course, I think on the capability side, we've added most of the capabilities that would be needed for network monitoring, from topologies which were missing, to network flows, to BGP monitoring, and we have a bunch of other things stored in the near future. So we can finally say that we are completely ready for full end-to-end network monitoring for all of our enterprise customers. And I'm also happy to share that we now have a whole new segment of customers coming into Netdata, also looking at network monitoring as a primary use case. Yeah, that's why come to Netdata. And then what is coming up? I think we did have this on some of the slides. You may or may not have paid attention. So over the next, we mentioned 90 days, but with Costa working on some of the stuff, it could be 9 days. But I've tried to be the product guy in general and try to put in some number. So first thing is kind of having anomaly detection and highlighting anomalies on the network topology maps. Also provide some kind of trends on NetFlow, the traffic analysis. Even if it is sampled or all of the data that is being sent. I think what is crucial is threat intelligence for us to be able to identify if there are any threats. And I think I have a typo in there. It's probably not on the topology maps, but in the NetFlow view. But Costa, you can correct me for the threat intelligence.
It's both. The whole point is to add it to both.
Absolutely.
Both on the map, both on the NetFlow.
Yeah. And then, of course, alerting based on NetFlows. So it's not currently available, but that's the next bit that we would be working on. In addition to, I think, what Costa mentioned, we want to be able to show alerts, link bandwidths, traffic, and things like that within the topology maps. So you have a visual representation of how your network is behaving. But those are the next things on the card. And I see a few more questions coming in, Costa, and I think we can take them as we speak. And I love the name 3D Aviation 686, not just for the name, but also for pouring in these questions. So, Costa, all yours.
So usually devices, especially the high-end devices, usually they are fast. They can do it even per second. Not all of them, however, and not for everything. So there are many cases where the metrics or some query freezes the SNMP processor. You need to be very careful there. Freezes, I mean, it has compute to do in order to respond, so it becomes unresponsive. Generally, what we see from customers is that 10 seconds is pretty much good, and it's not, it's not square, it's not 45 seconds average, for example, the same value. It's not like that. What we find interesting is that most of the traditional observability systems struggle with per minute, and even they have it every 5 minutes. And this is, this is strange for Netdata. Netdata is fast. So per second is standard. I hoped that we can do it per second. Customers stop us because they say, come on, not per second, because the little things are devices there with a little poor processor. So we believe that 10 seconds is a good starting point. And if you notice some delay somewhere on some device, Netdata visualizes gaps, which is very important. So unlike all other monitoring systems, Netdata is a watchdog. So if it expects something to be collected now, it has to be collected now. And if it cannot be collected now, this means this is a signal. No data or increased latency data collection is a signal for Netdata. So it shows gaps on the charts. If you see gaps on the charts, it's easy. You need to lower the data collection frequency in order to, because the device cannot do it. But for most of the customers, what we find out is that 10 seconds is pretty good. They don't have major issues. To tell you the truth, we have not tried to deploy massively at 5 to see what's going to happen. But so far, 10 seconds is good.
Yeah, I wouldn't want to go to 5 or even 1 second, Costa. I think 10 is already way better than what is currently on offer. And being on tens of hundreds of customer calls, I think we've already outdone some of it. So thanks for some of those inputs in there. And let me just very quickly, yeah, this is us summing up. What all do you need to do to get started on network monitoring if you already have not done it? You just need one Netdata agent. It could be on your Linux systems, Kubernetes cluster, or a Windows machine, or even a Mac or a FreeBSD. Not that I would hope that it's a production system still, and I hope they've gone away. But yes, a Netdata agent, enable the SNMP collector. We auto-discover. So you can give us the network, the credentials, and Netdata will automatically discover those metrics. Enable, of course, NetFlow if you want to use or install the NetFlow plugin. It's currently not part of the package yet, and I hope that it would be part of the package sometime soon. And then, of course, just view the topology, look at the net flows, and most importantly, provide us that valuable feedback, because we believe in continuously improving. We know it's not 100% perfect, and I don't think any solution can be 100% perfect. But with your feedback,
you can never be perfect in this world. Sorry.
Yes, but that's where I think with some valuable feedback, we can be as close as possible to perfect. Yeah, so that's basically the thing. We were supposed to come to the thank you and the questions, but we've handled quite a few questions. I think I see one more. And I think, Costa, I'll need to rely on you.
So guys, Netdata in general is an open platform. This means that all data that we have are exportable in multiple ways. For example, metrics, we have exporters for everything. You can move your data the way you see fit. Even download them in CSV files, whatever. It's your data, you should have access to them all the time. by all possible means, even to push them to Prometheus, to Grafana, whatever. For logs, we use Hotel and journals so far. We are changing that. We are releasing the next version. We'll have our own backend database for logs because we want it to be the fastest possible, let's say. So we managed to say, let's say that for the logs, we managed to achieve the best features of the others, of the best of all the others, the best footprint of the best of all the others. It's not the same. The best footprint, the best features are not the same. It's not the same other system. So we are releasing a new version that actually, for logs, can do, we have our own backend. But today, logs are, we can, you have journal.ctl to export them. Traps, again, the same. And NetFlows currently is also exportable with journal.ctl. You can export them all. Now, if you want to push them somewhere else, flows and traps, etc., traps already supports replay in Hotel. For NetFlow, actually, we have not implemented it, but it's kind of stupid. I think that if the first customer that will ask for this, we will do it, to export flows, re-export flows somewhere else.
Great. Thanks, Costa. I think we're hitting almost close to the hour, but I wanted this surprise. One last thing I want to show some of you guys. We've heard the feedback about our network dashboards. It's not the prettiest in the past, especially for the metrics. So what we've built is, I mean, we're building it. There's going to be an entire new UX flow, is a dedicated network monitor tab, which will have all of the data that you need for monitoring your networks in one place. So the network overview, all the devices, your network devices, all of the metrics in one place, but also topology and NetFlow, everything to be accessible from one dedicated tab for network monitoring. Because when Costa was, I think, demoing it, he went into the live tab, got into the SNMP section, and we understand, right? We are familiar with the UX. So sometimes it's easy for us to think that, oh, this is perfect. But we did identify it was not always easy to find various things. So this is another area you should be looking out for. Very soon, we'll have a completely revamped UX, especially for network monitoring. I think that's basically what we had. And for Ashmash XYZ, yes, we will definitely speak more on an onboarding session. If you book one with us, we're more than happy to answer any questions, guys. Feel free to reach out to us even after this webinar. So with that, thank you very much. Have a great day. Have a great evening. And see you next time around on the next webinar. Thank you. Bye-bye.
Bye.